So we have 6 different system properties: static and dynamic system, causal and non-causal system, linear and non-linear system, time variant and invariant system, stable and unstable system, invertible and inverse system. So these are all the system properties, right? These are said to be the characteristics of the system. So let us understand each of the properties one at a time. Let us understand static and dynamic system. How do you define a system to be a static system? So a static system is one which is in which the output signal at any specified time depends on the present value of the input signal alone. Static system are also called memoryless system. Right? So a static system is one in which output is function of only the present value of the input. Right? So it is not dependent on any other instance of input. That is why it is called to be a memoryless system. Whereas what is a dynamic system? A dynamic system is one in which the output at any specified time depends on the past or future value of the input signal. Right? So in a dynamic system, the output of the system is dependent on past or future values of the input signal. And that's why dynamic systems are also called a system with memory. Let me make the things easy for you by understanding these dimensions. So we will always represent xt as the input and yt as the output of the system. Okay, let these notations be clear. Xt represents the input, whereas yt represents the output of the signal. Right? So xt, whenever we have xt, it means that I am talking about the present input. Xt indicates the input, right? So xt with no operation done on this xt indicates the present input. Whereas these terms x of t minus 1, x of t minus 2 or t minus 3, what are all these? We call it to be the delayed inputs, right? So these are nothing but the past input signals, right? So x of t minus 1, x of t minus 2, x of t minus 3 and so on. If these terms are present in the output of the system, it indicates that the output of the system is dependent on the past inputs. Similarly, if your output of the system consists of the terms x of t plus 1, x of t plus 2, x of t plus 3, what we call all this as the advanced signals, right? And these are indicating the future inputs. Right? So all these terms indicate the future input. So if your output consists of these terms, then you call your output to be dependent on the future inputs of the signal. Right? This could also be put in other way. So x of t naught, I am taking some time instant t naught. So x of t naught indicates the present input. Then all the values of t less than t naught becomes the past input. And all the values of t greater than t naught becomes the future input. Right? So if x of t naught is the present input to the system, right? So all the values of the output which are having the terms t less than t naught indicates that the output is dependent on the past inputs. And if the output consists of the terms t greater than t naught, then it is dependent on the future values of the input. So these are certain guidelines for us with which we are able to identify whether the system is static or dynamic. Okay, so these are very essential terms which quickly helps us to identify or differentiate whether the given system is static or dynamic. So with this understanding, now let us try to solve certain problems which tells us to identify whether the system is static or dynamic. So let's look how the problems are framed. So it says that determine whether the following systems are static or dynamic. Okay, it says determine whether the following systems are static or dynamic. So what is the system given to you? Yt is equal to x of t plus 1 plus 5. Right, so look carefully. Here x indicates input Y indicates output of the system. So try to understand this very clearly. You have a certain input given to the system and your output of the system is dependent on x of t plus 1 with a quantity 5 added to it. Right, so yt is the output of the system and you are being asked to determine whether the system is static or dynamic, right? So yt is the output of the system. Right, now if yt is dependent on this parameters of the input signal, looking at its dependence on the input signal, you have to determine whether the given signal is a static system or it's a dynamic system. Now looking at the definition, right, what is a static system? A static system is one, right, which is dependent only on the present value of the input. Whereas what is a dynamic system? A dynamic system is one which is dependent on past or the future values of the input signal. So if you understand these definitions and try to apply to the given problem, right, here what do we understand? Output is a function of future value of the input term, right? Output is a function of future value. Here you could see x of t plus 1 indicates the future value. Advanced signals indicates the future values. So output is not dependent on present value. If output is only dependent on present value, you could have called this system as static. But since output is dependent on the future value of the input signal, you will call the system to be dynamic system. So how would you justify the answer? You would say as the output yt depends on future value of the input signal, the given system is dynamic system. Right? So given system is a dynamic system. Let us move to the next. Here yt is equal to xt sine of 2t. Okay, try to analyze the given system. So yt, the output of the system, is dependent on input in the form of xt into sine of 2t. So where is the input signal here? The input signal is xt. So rest of the term are some parameters associated with input. But here the input term is xt. So what we see that yt is function of xt alone, right? Yt is entirely dependent on the present value of the input alone. There is no past or future term associated with the input. Yt is a function of present value of the input and hence you call this system to be static system. Right, so as output yt depends only on the present value of the input signal, the given system is static system. This is how would you justify the system, the statement, right? So if I go back, a static system is defined as a system in which output signal at any specified time depends on present value of the input signal alone. It only depends on the present value, no past or no future values of the input. Right? If such is the situation, you will call the system to be static system, and this definition completely applies to the given system equation. Here output is only dependent on x of t. So you could see here input is neither delayed, it's neither advanced. So output yt depends on present value of the input. Right? And hence out is the system is a static system. Look at the next example. Here, yt is equal to x of t square. Yt is equal to x of t square. Now you need to specify whether the system is static or dynamic. Right, so since there is some t square operation involved, let us try to evaluate the output of the system for various time instants so that we identify whether output is function of present value or there are some past or future terms involved. So for that, we will analyze the system for t is equal to 2. So when t is equal to 2, right, y of 2. So can I say t is equal to 2 is nothing but the present value of the input now, because time instant is 2. So I am talking about the present time instant 2. So x of 2 is nothing but the present input, y of 2 indicates the present output, because I am talking about the time instant when t is equal to 2. So the moment we choose t is equal to 2, x of 2 indicates present input, y of 2 indicates present output. So y of 2, so what is the output at this present time instant? Y of 2 is observed to have x of 4, because 2 square is 4. So y of 2 is dependent on x of 4. Y of 2 is dependent on x of 4, and we know that x of 4 indicates the future input, right? So you can interpret this with respect to what we just discussed earlier. We discussed that if t naught indicates the time instant, right, then all the values of t less than t naught indicates past input, and t greater than t naught indicates future input. So with respect to the earlier problem, what was t naught? The time instant that we had chosen was 2, right? And output y of 2 was dependent on x of 4. So x of 4 means you have a time instant which is greater than t naught, right? And hence there is a future input involved in the solution of the earlier problem, right? And hence what we understand here is that with the present time instant t is equal to 2, what is nothing but 2, y of 2, that is the present output, is dependent on some value of the input which is the future value of the input. So here t is greater than t naught. T naught is 2. So t means here 4. So 4 is greater than 2. It means that we are considering future value of the input. So output is a function of future value of the input. Similarly, if you want, you could, even if one term is identified, you can quickly say that the given system is dynamic because it's not future input. In case if you want, you can check several other values of time instants. When you say t is equal to -1, so y of -1 becomes the present output. Right, x of -1 becomes the present input because we are talking about the time instant t is equal to -1. What we observe? Y is equal to -1 is x of 1. -1 square is 1. So x of 1 with respect to y of -1 becomes the future value. And hence, how would we say that? As output yt depends on future value of the input signal, the given system is dynamic. Right? Let's look at the other example now. So here yt is equal to x of t minus 3 and x of 3 minus t. So t minus 3 and x of 3 minus t. Right? So is this term x of t minus 3? It's definitely not the present input. It is input which is shifted in time. So x of t minus 3 indicates the past input. Whereas x of 3 minus t, what is this term? Right? So for that you could rewrite your system equation, right? So how would you could rewrite your expression is in here advanced signal. Here it is delayed signal. So delayed signal means past inputs. Advanced signal means the future inputs. Right? So here you could see easily that you could easily analyze that output is a function of past input and output is also a function of future input. So if any of the term is present in the output, if output has either a past term or a future term, then the system becomes dynamic. For the system to be static, output should be only the function of present input xt. But here there is no present term at all. Instead, there are past and future terms involved, and hence the given system is dynamic system. Right? The given system is a dynamic system.
of 1. So with respect to time instant 4, x of 1 time instant indicates the past input. With respect to t is equal to 4, if my present input time instant is 4, then x of 1 indicates the past input. X of 4 would have indicated present input, but it is x of 1 here. It means that it is past input. So output is a function of past input. Similarly, if I take another time instant, t is equal to minus 8. So what is the output? Now t is equal to minus 8 becomes the present input time instant. Present input time instant. Right? If there would have been a term x of minus 8 involved in the system output, that becomes the present input. Any other time instant of the input either may indicate a past or a future. So let's analyze it. So y of minus 8. So the moment I put t is equal to minus 8, I get here x of minus 2. So with respect to t as minus 8, x of minus 2 indicates the future value. Right? T is greater than t naught here, and that's why it is the future input. So as output depends on past as well as future value of the input signal, the given system is dynamic system. Right? So it is very essential that you understand these definitions very properly. Right? So if the output of the system has only present input, if output is dependent on only the present inputs, you call the system to be static. The output of the system, it depends on the past or future values of the input signal, then you call the system to be dynamic. Okay, even if there is past or any future value involved, any of these term involved, maybe past, maybe future, you will call the system to be dynamic system. Right? So the understanding of these statement is very essential. Right? So when output is only a function of present input, no past or no future term, that's why we don't need any memory. And that's why static systems are said to be memoryless system. Whereas when output depends on past values or future values, to record the past values, you need certain memory. To retain the to keep a record of predicted future values, you need a memory. So memory gets involved, and that's why dynamic systems are said to be the systems with memory. So memoryless systems means static systems. System with memory means dynamic system.